and the interest rate is going to be 8%. Okay? Okay, so you have 12 payments per year for 20 years. That's 240 payments at $1,254.68. So that gives you a grand total of $301,123.20. So the next question is, what amount of the total is interest costs? So you subtract $150,000 from that, and you get 151,123.20. All right, 55 is asking that you guys use a change of base formula and a graphing calculator. So this is what you would input, like on a program like Desmos or a handheld graphing calculator. You would put this in and get your graph. But I'm going to go ahead and just continue using the transformations and graphing it by hand. Okay, so then we have 1 plus 2, that's 3, and 2 plus 2, that's 4, and then we're going to graph it. So with h being positive 2, that means that the vertical asymptote is moved to x equals 2, and then the points 3, 0 and 4, 1, and then connect them. Okay, and that's all that it's asking for. So if you graphed it on a graphing calculator using this, you'd get the same exact picture that you see here. Okay, so I'm going to rewrite number 60. They only want you to use log base b of 2, log base b of 3, or log base b of 5. Okay, so I don't want to see any 4s or 9s in the problem. So the first thing I'm going to do is use the property of logs that expands this. So instead of log base b of 4/9, I'm going to write it as log base b of 4 minus log base b of 9. Okay? Now 4 and 9 are square numbers. And so I could rewrite this as log base b of 2 squared and log base b of 3 squared. And the only reason I'm doing this is because, remember, I could only use the 2, the 3, and the 5. Okay, they don't want to see a 4 or a 9. So this and this exponent become coefficients of their log, like that. So it becomes 2 times log base b of 2 minus 2 times log base b of 3. So now I just replace or substitute log base b of 2. Okay, so I just did the substitution right here. This is log base b of 2, log base b of 3 that was given to you. And so plug this into a calculator and you get negative approximately equal to negative 0.4166. Sorry, 68. And that would be the answer. So they want you to simplify the expression, rewrite it and simplify using the properties of logs. So the first thing that stands out is that 200, because I see that the base is 10, and I know that 200 is 2 times 100, and 100 has base 10. So log, I'm going to use the properties of logs that say that if I have the log of a product, because here I have a product, right, 2 times 100 is the same as log base 10 of 2 plus log base 10 of 100. Now log base 10 of 100 is 2 because 10 squared is 100. So remember, log is an exponent. So what exponent of 10 gives you 100? Well, the answer is 2. So this is 2. So this becomes 2 plus log base 10 of 2. And that's as simplified as you can get it without using a calculator. Okay, so for 70, they want you to expand it. So first thing I'm going to do is use the property that says that the log of a quotient is equal to the difference of the logs. So like this. And then square root of x is the same thing as x to the 1/2. And so this 1/2 right here becomes the coefficient of the log. So 1/2 natural log of x minus natural log of 4. And that's the answer. Okay, so for 75 we're doing the opposite, where we are condensing the log. And first thing we're going to do is take the coefficients and put them back to their respective exponents. So here, and the 1/2 is going to go here. So this is natural log of 2x minus 1 to the 1/2 minus natural log of x plus 1 squared. Now remember, the difference of two logs is this, if the bases are the same, is equal to the log of the quotient. So this becomes natural log of 2x minus 1 to the 1/2 over x plus 1 squared. Now we can get rid of that 1/2 and write it as the square root of 2x minus 1 like that over x plus 1 squared. And that would be the final answer. Alright, so for number 80 you have a function that will, a logarithmic function that tells you the average score of a repeated test after time t being months, and it has to be within 10 months, right? T is between 0 and 10, less than or equal to 10. So the question is, how much time will it take between tests so that the score goes down to 68? Okay, so we're looking for t when f of t is 68. So the f of t is 68, and I have 85 minus 17 log of t plus 1. So first thing we'll do is subtract 85. And so that's going to give us negative 17 equals negative 17 log of t plus 1. Well, I'm going to divide by negative 17. Okay, so then that's going to give me 1 on the left side, so 1 equals log of t plus 1. And I know the base is 10, right? Because I didn't write anything here on the base, so it's 10. So it's 10 to the first power, because that's my exponent right here. 10 to the first power equals t plus 1. So subtract 1, and so we get 9 equals t. So it'll be 9 months for a person to get a score of 68. Alright, so 85, solve without using a calculator, and this is similar to one of the quiz questions I gave you, where a lot of you guys used a calculator, but it would have been a lot faster and less work if you hadn't. So 16 is 2 to the 4th, right? But here I have on the right side 1 over 16. So I can change it to base 2 if I made this a negative 4. So now 2 to the negative 4 is 1 over 16. Now why do that? Because if I can get the bases equal, then I could set the exponents equal to each other. So now I could just say x plus 1 is negative 4. I'm going to subtract 1, so x is negative 5. Okay, so number 90, log base 5 of 2x plus 27 is equal to 2. It's in logarithmic form, so I'm going to change it to exponential. My base is 5, my exponent equals 2, and it equals 2x plus 27. So I've got 25 equals 2x plus 27. I'm going to subtract 27 from both sides. So I have negative 2 equals 2x, divide by 2, so x equals negative 1. Alright, so we're going to solve 95 algebraically and then round the answer to 3 decimal places. So first thing I'm going to do is divide by 3 to isolate the e to the negative 5x. So now I have e to the negative 5x equals 44. Okay, so I can't do 95 like I did 85 because I cannot get the basis to equal on each side. So I have to solve it either by taking the log of both sides or by just switching the form from exponential to logarithmic, and that's what I usually do. So this is natural log of 44 equals the exponent. Solve for x. So this would be the exact value right here, but then they want you to give the rounded answer, right? So when you put that into the calculator, you get negative 0.757 when you round it to 3 decimal places. Okay, so I'm going to divide by 2. So I get 12 to the x equals 95. Okay, I can't get 95 and 12 to have the same base. So I'm going to change it to log form. So this is log base 12 of 95 equals x. This would be the exact value, or if you do change of base theorem, it would be x equals natural log of 95 over natural log of 12. Remember, you can do natural log or you can do common log, and then this would be the exact value. So the approximate value, okay, so here's the approximate value right here. When you plug it into the calculator, this is what you get. Alright, so now it's going the other way, that we have logarithmic equations that they want you to solve. So when it's in, you could exponentiate both sides, the equation, but I usually just switch it over to exponential. It's in log form, I'm going to switch it over to exponential. With natural log, the base is e. So e to the 6.4, because that's the exponent, equals 3x. So I'm going to divide by 3. Okay, so x equals e to the 6.4 over 3. This is the exact value. For the approximate value, we get 200.615. This is the approximate value right here. So I have both exact and approximate. Alright, for 110 I have two choices. I can either change the radical to a rational exponent like this, like that. Bring the 1/2 over to the front, so I have 1/2 natural log of x plus 40 equals 3. Then I could multiply both sides by 2 to get rid of the 1/2. So now I have natural log of x plus 40 equals 6, right? 3 times 2 is 6. Change it to exponential. So from here, just put it right here, it's going to be e to the 6th power equals x plus 40. So x is e to the 6th power minus 40. So that would be the exact value. The approximate value is 363.43. Alright, so for 115, one thing I noticed is that both of them have the e to the x in common. So I'm going to factor it out of both terms. So then when I factor out e to the x, in the first term I have x as my other factor, plus, and then I factor out e to the x from the second factor, I'm left with 1. So now I have the product of these two equals 0. Well, then that tells me that either e to the x is 0 or x plus 1 is 0, right? The zero product property. So for the second one, x is negative 1. For the first one, e to the x equals 0 is impossible, because no matter what you put in place of the x, you're never going to get a 0. Positive numbers, even 0 gives you 1. And the negative numbers give you very small values, but never 0. So this one is not